All right, welcome to day 4. In our planners, we want to be writing day 4 down. Let's have your homework out from day 3 so you're ready to check it when we get there. And we also need our warm-up sheet out to try these 2 warm-up questions. They're true, false. If it's true, all you've got to write is true. But if it's false, in addition to writing false, you have to correct the statement or write it in a way that we know it is true. So we're going to pause the video for 3 minutes for you to do those 3 things. Write in your planner, warm up out, and have homework out as well and be working on the warm up. So the first one, we have it worded just slightly differently on our cards, but we got both pairs of opposite sides and congruent or parallel implies parallelogram, and that is true. The second one pair of opposite sides parallel and the other pair congruent. Well, in a picture, that would be having like those parallel and those congruent. That does not give us a parallelogram. That's not true. We would need the same set of sides being both congruent and parallel. So this is false, and we could correct it by saying one pair of sides congruent and parallel implies parallelogram. All right, we can stick our warm-ups away and let's move over to the homework. Our goal here was to get a parallelogram. So we want to either get one pair of sides, congruent and parallel implies parallelogram. That's the most commonly used one. The other 2 most common ones are both pairs of opposite sides parallel implies parallelogram, or both pairs of opposite sides congruent implies parallelogram. We were given a set of sides congruent, so that rules out pretty much the both pairs parallel. And then we had a set of angles congruent. Well, notice those angles are alternate interior angles. So congruent alternate interior angles implies parallel lines. Now we have the same set of sides, both congruent and parallel. So one pair of sides congruent and parallel implies parallelogram. Going to the second one. On our givens, we were given one of the set of opposite sides, S, V, and TD, congruent. So that rules out both pairs of opposite sides parallel. Based on our other givens, we have a set of sides in that triangle. We have perpendicular lines, which we can do right angles. Right angles implies right triangles. And now we have 3 things in these triangles. But it's side-side angle, which normally doesn't work. But the one time it does work is if you have a right angle. So we can do our one extra step, the right angle implies right triangle, and then do HL congruent to HL to get that top and bottom triangle congruent. Well, once you have the triangles congruent, you can get any other pairs of angles or sides congruent in those triangles. A strategic ones would be the ones that I labeled 3 and 4. So we can say those are congruent by congruent triangles, implies congruent corresponding parts. Well, if you do your zigzag now, that will make SV and TD parallel because congruent alternate interior angles implies parallel lines. And now we have one pair of sides that is both parallel and congruent. So we can say we have a parallelogram. And in the third one, we had some givens there. We eventually want CHMD to be a parallelogram. Well, notice they told us in that triangle that the 2 base angles were congruent. That implies isosceles triangle for triangle HME. And then we can do isosceles triangle implies 2 congruent sides. Notice with the markings in our sides, HE got marked up twice, so we can do a transitive property to get CD congruent to HM. Then they had told us that angle D and angle 1 were congruent. Notice those are both in the top right of their intersection if you extend the lines. So that's congruent corresponding angles implying parallel lines. Well, now CD and HM are both congruent and parallel. So we can do one pair of sides congruent and parallel implies parallelogram. So we're going to skip the one on page 16 in this video because we'll probably only have time for 3 of the 4. So let's flip over to question 2, which I believe should be on page 17 in your packets. And we're going to look at some proving a parallelogram that's a little bit trickier today. So let's go ahead and get our statements, reasons, and givens down. So we've got PT congruent to VR, so let's mark that up. Now, one thing that's confusing here is notice we're given a parallelogram and we want to prove a parallelogram. Well, the one we're given is the big one, and the one we want to prove is the inside one. So in that inside one, we want to either get one pair of opposite sides congruent and parallel, both pairs of opposite sides parallel, or both pairs of opposite sides congruent. And in general, you usually try to get some triangles congruent and then work from there. So the fact that the big one is a parallelogram, we can do all of our stuff that a parallelogram implies for that. Well, let's start with parallelogram implies opposite sides congruent. At the start of the proof here, we're not quite sure which ones we might need, so let's just go ahead and say both pairs. So we'll do QP is congruent to RS, and right in the same statement, we can do PS is congruent to QR. We said it in our proof, so we should mark in our picture. We'll put 2 marks on one of them, 3 marks on the other. Well, in the left and right triangles, notice we have 2 marks. In the top and bottom triangles, we have 2 sets of marks. So if we could get one more thing in each of those, then we could get some pairs of triangles congruent. So what we're going to do next is let's get this opposite sides parallel in the big one, which will allow us to then do parallel lines implies congruent alternate interior angles. So we're going to do parallelogram implies opposite sides parallel. And those same set of sides that we said were congruent, we're going to say that they're parallel. We can put our little arrowheads on them. Remember, the arrowhead doesn't mean congruent. The arrowheads mean that they're parallel. And the parallel lines can imply congruent alternate interior angles. So we want to think our zigzags. If I did a zigzag going this way, I would have this angle and this angle, so I'm going to call it 1 and 2. If I did a zigzag going this way, I would have these angles 3 and 4. So our reason is going to be parallel lines implies congruent alternate interior angles. And our statement is just going to be angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. We said it in our proof, so let's mark them up in our picture, and our picture's starting to get a little bit messy. But notice in top and bottom triangle, we have two sides and an angle. The angle is between the marked sides, so that's side, angle, side. Same deal on the left and right triangles. So we can next do side, angle, side, congruent to side, angle, side. And our statement would be the pairs of triangles congruent. So I'm going to start with triangle QTP is congruent to triangle. So QTP was the left triangle there. Q is going to match with S. T will match with V. And then we'll have R to finish it out. And we'll do the other triangle right in the same step. We'll do QRV. It's congruent to triangle. If we did Q in the top one, that should match with S, so we'll need SPT for that one. Well, once you get the triangles congruent, remember we can get any additional sets of sides and angles congruent within those triangles. Well, that will allow us to get the opposite sides of the inner thing we're trying to get to be a parallelogram congruent. So we're going to make TS and QV congruent and QT and VS congruent by our congruent triangles implies congruent corresponding parts. So we said triangles were congruent, so we have congruent triangles implies congruent corresponding parts. And that'll be that QV is congruent to its opposite side, TS. And QT is congruent to VS. So if we go to our picture now, notice in that inner one, TSVQ, we now have both pairs of opposite sides congruent. So we're ready to say it's a parallelogram. So our final reason will be both pairs of opposite sides congruent implies parallelogram. And our statement is just that TSVQ is a parallelogram. All right, let's flip over to the next page, I believe. I believe this should be on page 18. So this proof is similar in that the outer one is a parallelogram. We want to get the inner one to be a parallelogram. So we're going to do some similar type things here. So let's go ahead. We'll do our statements, reasons, and givens. All right, well, we've got some perpendicular lines. Let's maybe go with that. So we can do perpendicular lines implies right angles. So let's find where PC and QS meet. And we'll number the angles there. So I'm going to call this 1 and 2. And then RD and QS, they're meeting here, so I'm going to call them 3 and 4. So we're just going to list that all of them are right angles. So angle 1, angle 2, angle 3, angle 4 are right angles. Automatically next, we want to say right angles implies congruent angles. And we'll just do a long string of all those being congruent. Angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. And we want to do all 4 of those. We don't know which ones we'll end up using in the long run, so might as well just say them now so that we have them in case, and then you can put your boxes in for each of them. So notice in terms of our outer triangles, in the left-hand and right-hand triangle, we have one angle now. So let's maybe see if we can keep working with those. We could add our parallelogram stuff for the outer one. So let's do parallelogram implies opposite sides congruent. And we can do, because we don't know which ones we'll need, let's do both sets. We'll have QP and SR congruent. And throw in the other ones as well. PS is congruent to QR. Again, we don't know which ones we'll end up needing. So we'll mark those pairs congruent in our picture. So in the left and right triangles, we have 2 things, a side and an angle. The top and the bottom, there's only 1 thing. But let's do like we did in the last one. Let's do parallelogram implies opposite sides parallel next. So we would say QP is parallel to SR. PS is parallel to QR. And in our picture, we mark that with little arrowheads. Keep in mind that arrowheads does not mean congruent, it just means parallel. And then once you have parallel, you can do your alternate interior angles congruent. So we can do the same thing that we did on the last one. So I'm going to number these 2 5 and 6, these 2 7 and 8, and that's coming from our zigzag, those alternate interior ones. Now they're not all congruent to each other. Just 5 and 6 are congruent to each other, and just 7 and 8. But we'll do our parallel lines. Implies congruent, alternate interior angles. And we said that was angle 5 congruent to angle 6, comma, angle 7 congruent to angle 8. Again, we don't know which ones we'll end up needing. So if we mark 5 and 6 congruent, 7 and 8 with a different number of marks. Notice in the left-hand and right-hand triangle, we have 3 things marked. We have 2 angles and a side not in between. Top and bottom, though, we only have 1 angle and 1 side. So let's go ahead and work with the left-hand and right-hand triangles because we have enough to get them congruent. Again, we have 2 angles and the side not in between marked up. So that would be angle, angle, side, congruent to angle, angle, side. Just name your first triangle anything you want. So I'm going to call the first one QPC. And then we got to be careful in the second one to get it to match. So Q was here at our alternate interior, so that should match with S. P had no marks, so that should match with R. So we need SRD to match up. But once we have congruent triangles, we can get any other pairs of sides or angles congruent. Notice a pair of sides in those triangles happens to be in the quadrilateral we're trying to get to be a parallelogram, PC and DR. So let's use now our congruent triangles. Implies congruent corresponding parts. To get those sides in our triangles that are also in the quadrilateral that we're trying to get to be a parallelogram. So we can say PC is now congruent to DR. Well, let's mark that up in our picture. Let's see, I'm up to 3 marks. So we've got a set of opposite sides congruent there. Notice angles 2 and 3. Those are actually the angles of our zigzag there. So we actually already have congruent alternate interior angles. So we're in pretty good shape here. We can now say congruent alternate interior angles implies parallel lines. And that'll give us that the ones we just did the zigzag with, PC and DR, are parallel. Well, if you look at steps 10 and 11, notice we have the same set of sides as both congruent and parallel. So we're in good shape to get a parallelogram. We can say one pair of sides, congruent, and parallel implies parallelogram. And our statement is just what we wanted to prove. PCRD is a parallelogram. So that proof's kind of involved, but it follows their same principles with the other one that we did. We had a big parallelogram. Use your things that parallelogram implies to get triangles congruent eventually. Then use congruent triangles implies congruent corresponding parts to get things in the inner parallelogram, or the one that we want to eventually be a parallelogram, so that we can get that to be what we want. All right, one last one for this video. If we go over to number 4, we'll give you a minute to get down the statements, reasons, and givens. It's okay to abbreviate the word parallelogram, again, with our symbol. We can mark up the DF and the EB. So a pretty similar idea. Let's use stuff from the outer parallelogram and what it implies to eventually get triangles congruent, and then get stuff in the inner quadrilateral to be a parallelogram. So let's start with parallelogram implies opposite sides congruent. We can use that to get AD congruent to CB, and DC congruent to AB. We'll put a different number of marks on each of those pairs. Well, because we've got one of the diagonals there, we'll eventually, if we can get the opposite sides parallel, we can eventually do some congruent alternate interior angles. So let's next do parallelogram in the big one. implies opposite sides parallel. And we'll say AD is parallel to CB, DC is parallel to AB. We can put our arrowheads on, and remember, that does not mean congruent. That means that they are parallel. But doing that allows us to do our zigzag to get congruent alternate interior angles. So if we do that zigzag, I'm going to call those 1 and 2. And if we did our zigzag going this way with our parallel lines, I'm going to call those 3 and 4. So we can now say that our parallel lines will imply congruent alternate interior angles. And we got 2 pairs there. Make sure we're doing greens congruent to greens and blues to blue. So we got angle 1 congruent to angle 2, comma, angle 3 congruent to angle 4. And once you say it in your proof, we can mark those angles up in our picture. And it's a little messy with all our markings, but in both top and bottom triangle and the left and right triangle, we have 2 sides with an angle in between. That means that we can do side angle side congruent to side angle side. So let's see, our left-hand triangle, we could call triangle DAF. Congruent to triangle. So D in that triangle was our alternate interior. That should match with B. A was kind of towards the outside, so that should match with C, and then E comes in. So that's one set of triangles. The other one, I'm just going to name the top one DFC. Is congruent to triangle. So D was our green alternate interior there. That should match with B in the other triangle. F is the angle that came towards the middle, so that should match with E, and then A. Well, just like we've seen in the other proofs on this video, after you get the triangles congruent, we'll do our congruent triangles, implies congruent corresponding parts. And the purpose of this is to get other things in the triangle that will help us get AFCE to be a parallelogram. Well, we can do those extra sets of sides that will end up being the opposite sides in the parallelogram. So we can say that AE is congruent to FC. And we can also say that AF is congruent to EC. Well, we are ready to finish this proof because in AFCE, notice we have 2 pairs of opposite sides marked congruent. So we can say both pairs of opposite sides congruent implies parallelogram. And our statement is just AFCE is a parallelogram. So notice with all these, when you're given the outer one as a parallelogram, there's some inner one we want to be prove a parallelogram. It's pretty standard procedure. We used parallelogram implies opposite sides congruent, opposite sides parallel. Those opposite sides parallel implied congruent alternate interior angles, and we use that stuff to get congruent triangles. And then the congruent triangles implied congruent corresponding parts to get us things in the inner quadrilateral that we could eventually use to make it be a parallelogram. That's it for this video. Any time left in the period you can use to start the homework. Have a great rest of your day.